Here we're going to prove that the limit as x approaches 0 of 1 over x to the fourth power is equal to infinity. Now remember, this limit doesn't actually exist. What this actually says is that the values of y as x gets closer and closer to 0 grow infinitely large. That's what it's indicating. Here's our outline that we're going to use to do this proof. Let's start. We see that given any positive m, this is part of the definition, given any positive m, we want to find a positive delta such that 0 less than the absolute value of x minus 0 less than delta implies that 1 over x to the fourth, our function, 1 over x to the fourth, is greater than this m. Well, if that's what we are going to find, that means is the same. That's the same as 0 less than absolute value of x less than delta implies x to the fourth power is less than 1 over m. You see, I did a cross product equals I multiplied both sides by the LCD, which was a positive number, and I turned everything backwards. Okay, now we're going to consider the fourth roots. This implies that 0 less than the absolute value of x less than delta implies that the absolute value of x is smaller than the fourth root of 1 over m, which is 1 over the fourth root of m. All I did was take the fourth root of both sides of the right side of that implication. So what we want is the absolute value of x to be smaller than 1 over the fourth root of m. Okay, well, we're assuming that the absolute value of x is smaller than delta. Thus, all we have to do is choose delta equal to 1 over the fourth root of m. Step 2 says, okay, we're going to assume that 0 less than absolute value of x minus a less than delta, and we're going to choose delta, as we have above, 1 over the fourth root of m, and show that f of x is greater than m. That's all we have to show. So assume 0 is less than the absolute value of x minus 0 is less than delta, and let delta equal 1 over the fourth root of m. Then let's do the proof. F of x is equal to 1 over x to the fourth power by definition, which is greater than m, and here's why. It's because saying that the absolute value of x is less than delta implies that x to the fourth power is less than delta to the fourth power, and that means that the reciprocal of 1 over the x to the fourth is actually greater than 1 over the x delta to the fourth reciprocal, and that itself is equal to m. That's why this is true. And of course the equality at the end for m is true because delta is equal to 1 over the fourth root of m, which changes when you solve for m to 1 over delta to the fourth power. That's where that came from. Okay, so it's just manipulating algebraically, and our conclusion is that the limit as x approaches 0 of 1 over x to the fourth is equal to infinity by the definition of such a limit.